Is it possible that the big fossil fuel companies would become leaders in moving over into renewable fuels? So instead of thinking of themselves as oil companies, if they thought of themselves as energy companies trying to sell energy however it's manufactured?
They can, but they've done a poor job so far. It's more likely the scenario would be something like in transportation. You could see it with Tesla Motors. I mean, they're a brand new company. They didn't start from an existing big three auto company. They started on their own. They developed a great new technology that works. That's great cars that can go now over 300 miles on a single charge, can be charged in an hour, and they even might have battery swapping where you can actually swap it within 60 seconds. Accelerate really well. So it'll probably be the model maybe that companies who just develop a focus on clean renewable energies will be the ones that come out ahead, and the existing oil companies and the existing automobile companies, they're going to still persist and they'll gradually change, but probably not so fast as emerging companies that just are focused on clean energy.
Well, I saw that General Motors is now going to launch an all-electric car to compete with Tesla. So Tesla is creating the market, and the big automakers are saying, hey, there's a new market here. We don't want to be left out of this.
Yeah, that's great. I mean, the more the better, because that'll drive the prices down, that'll more competition, that'll allow more variability in terms, or improve the technology faster and gain wider acceptance among the public. So that's great if they do that.
Would you say that nuclear energy is basically dead at this point as a future energy source?
Yeah, well, it's not growing. I mean, there were 440 nuclear reactors in the world 2 years ago, and after Fukushima, that dropped down significantly to around 400. In the US, we're not increasing, we're actually dropping out a couple of reactors. And nuclear it's so costly, and it takes so long to put up a single nuclear reactor, basically between 11 and 19 years between planning and operation of a reactor versus 2 to 5 years for solar or wind, that while you're waiting around for one nuclear power plant, the Arctic ice will be melted, because the Arctic ice is expected to melt entirely in the summers within 10 to 30 years. So we really can't afford to wait around for nuclear. Nuclear still puts out between 9 and 25 times more carbon dioxide emissions and air pollution than wind energy per unit electricity generated. So it's not a totally clean carbon source. It's cleaner than other fossil fuels, but not as clean as wind or solar. Plus, it has the radioactive waste issue. It also has the issues of leakage through meltdowns. 1.5% of all nuclear reactors ever built to date have melted down to some degree.
A slight accident could take away your entire investment very easily.
Right, and also there's the nuclear weapons proliferation issue that 5 countries of the world have secretly developed weapons under the guise of civilian nuclear energy programs. So it's probably not going to grow very much, if at all, and it's not something that we would think is a good technology for the future, because wind and solar do not have catastrophic risks problems like nuclear does.
Where is most of the research in solar energy? Is there research being done on ways to make it more efficient? I mean, are you limited, like you just can't get more solar energy than falls on a certain space?
Well, solar does not, so I'll give you an example of how much space it takes for solar. If you want to power the entire US vehicle fleet, starting with wind, you would need about 73,000 to 140,000 5-megawatt wind turbines. And that would take up about 1/3 the size of South Dakota, which is, just to put in comparison, is about 1/30th the land area needed to do the same thing with corn ethanol. So you need 30 times, 1/30th the land area for wind turbines to power the US vehicle fleet than corn ethanol. And that's just the spacing area, and you can use that space for many purposes, like agriculture, open space. But solar is about 1/3 of that. So solar it takes about 1/90th the area to run the whole US vehicle fleet than corn ethanol does. Because photosynthesis for biofuels is only 1% efficient. And whereas solar, it has a higher efficiency in terms of converting sunlight into electric power in this case. And this is, by the way, for solar energy or wind energy running battery electric vehicles versus ethanol for combustion vehicles. And so it doesn't take up a lot of space, but there are energy efficiency improvements that are continuous. There are a lot of people researching and trying to make better solar panels. and there's also a growth of solar, and that's driving the price down. And wind is also being made more efficient, although there's not a huge amount you can do to improve the efficiency of wind energy.
I thought there were some problems with wind turbines because birds fly into them and damage them. And
well, the birds don't damage the turbines, but there are bird kills from wind turbines. But to put it in perspective, the bird kills from wind turbines are about 1/10 the bird kills of either natural gas or coal per unit of electricity generated, because natural gas and coal kill birds through land degradation during mining process, due to the air pollution from them, and due to actual buildings that they run into. And so it's actually a red herring to say that wind is bad. It does kill birds, but it's 1/10 those of natural gas or coal.
Is there any way to capture really big wind events? So, for example, if you could capture the power in a tornado or a hurricane, that would be a lot of power that could last a long time.
Yeah, we've studied the impacts of wind turbines on hurricanes, and we found that if you have large arrays of offshore wind, you can actually not only generate electric power during the year when the hurricane is not even present, thereby paying for the wind turbines. But when a hurricane does come along, you can actually dampen a hurricane. You need a lot of them, but you can actually reduce the storm surge, which causes most of the damage, by up to 70%, we found for a simulation of Hurricane Katrina. And the more standard scenarios might be 50%, which would be a huge reduction of the damage. And so the alternative is, well, you can put up seawalls, which in the case of New York, after Hurricane Sandy recently, the governor or the mayor of New York City proposed seawalls off of the coast of New York City. And this would cost a huge amount, and it would not generate any electricity. So it has one purpose, and it might reduce damage. But we found that you can do the same. You can reduce the damage in a similar way with the offshore wind turbines while generating electricity year-round, thereby paying for the turbines. So you serve multiple purposes with offshore wind turbines.
Now, in recent years, the price of gas has gone down quite a bit because of fracking, this horizontal drilling where you break up rocks and release gas in it. But that seems to have a lot of potential and real environmental problems. Do you think that the fact that it's so cheap will let us keep using fracking even though it does have problems compared to these natural sources?
Yeah, I mean, certainly the low price of natural gas due to fracking is pushing its use more. But this is why policies need to be put in place to address this. I mean, the environmental side effects of fracking are not only groundwater contamination, but also air pollution, but methane release, which in methane is one of the main leading causes of global warming, but it also is one of the main leading causes of Arctic sea ice loss. And so it's a mistake to think that natural gas is what's called a bridge fuel, because it actually enhances global warming compared to wind and solar significantly. It's on the order of 60 to 70 times more global warming emissions per kilowatt hour generated of electricity from gas versus wind.
And we're going to have to wrap on that note because we are out of time, unfortunately. I'd like to thank my guest, Mark Jacobson, atmospheric scientist from Stanford University. And thank you for watching. Visit our website, www.futuretalk.net. For Future Talk, I'm Marty Wasserman. We'll see you next time.